Okay, so second part of the video here, we're going to be talking about how we went from what the ancient Greeks had taught us about motion into what this lovely guy by the name of Copernicus taught us. Now, Copernicus, although his name sounds Latin, he was actually a Polish mathematician and astronomer, and he formulated the theory that the Earth was moving, and he got this theory from his astronomical observations. He observed a lot of stuff about the moon and the stars and other planets that he could see with the naked eye, and he plugged it into some of his math and realized that, hey, if the Earth is stationary, the math doesn't work. So let's try it if the math is moving, or the Earth is moving, and the math worked. And so he published this theory in 1543, and needless to say, his theory was not all that popular, and he was actually imprisoned, and it was illegal for quite some time to actually teach his teachings in his theory. But as often happens in science, people searching the truth will seek out anything that potentially leads to the truth, and so they will learn these things even though they're illegal. And along comes the guy by the name Galileo, whom I'm sure you've all heard of. He was an Italian scientist whose work in the 17th century helped unlock many secrets of astronomy and natural motion. Galileo was a very big astronomer, and in fact he actually invented one of the first telescopes and was the first recorded person to record any observations of the moons of Jupiter, and that's pretty cool. And with his observations using his telescope, he was able to show that Copernicus was actually right, and that he was the first to show that Earth moving was actually a reasonable concept. He came up with this idea of force. Well, he didn't really come up with the idea of force, but he described it as any push or pull, and that force went along with a lot of the ideas that he had. And so from that, he kind of thought of some other forces, and I'm actually going to let Mr. Bendersky discuss one of the forces that he kind of discovered.
One thing Galileo would do after agreeing with the Greeks in terms of force is he could find a new force for us. And what Galileo did is he did hundreds of experiments with arc-shaped pieces of wood like this. And he had these made of every wood available: oak, maple, elm, olive. And he would take these bows of wood, and he would take marbles, glass, ceramic, and he would release the marble from one side, and he would record how far up the other side each of the marbles would go. And he realized that as he used different marbles, that they would go different heights. And he realized that as he used different woods, the heights obtained by the marbles would change. So this showed Galileo there was another force involved, that there was a force that existed between materials that passed by each other. And he would call this friction.
So as you can see, he kind of coined the term friction. And Galileo defined friction as a force that acts between materials moving past each other. And that's pretty much what our understanding of friction is now. So he kind of concluded that if there was no friction, friction acts between things. So if there was no friction, then there would be nothing to keep something or stop something from moving. So if there was no friction, then force would be needed to keep an object moving. So you could just keep on moving and moving and moving, and no friction meant you kept going. Now, that's not completely wrong, but what Galileo fell short is he went a little bit too far. He then extended that to say that since friction makes things stop, things don't actually want to stop, and so they're natural for them. It's not natural for them to be at rest, and if you remove friction, then things would just keep moving and always be moving, and that's not quite our understanding anymore. Now, along with all of his studies and his work, he came up with this idea of inertia, and inertia, as he called it, was the resistance to change in the state of motion. Inertia actually means lazy, and so when you're talking about something that's lazy, it doesn't want to move. It's hard to get it to move if it already is moving, or it's hard to get something that's lazy to change. And so that's what inertia is, basically. there's no friction in space, and objects don't want to change what they're doing, so they're going to keep moving. So he kind of concluded that the Earth and all of the planets coast around the sun without loss of speed. Because there is no friction, there's nothing to make them stop. So they just keep going around and around and around and around and around. And we're going to continue on with Newton's laws in the next video.